Everyone seems to think I hate GraphQL, and it's annoying because I don't. I actually think GraphQL is a great solution. I just don't think it's the right solution for everybody. And if you have the ability to avoid it and provide a better experience, you should. If you have a backend and a frontend that are in the same language, that language is TypeScript, and ideally the code is in the same project, in the same repo on GitHub, it's very easy to use something like tRPC or any of the other solutions like it to share types from your backend to your frontend. And it's even easier to go define a new query on the backend if you need a new shape for your data on the frontend. The ability to move fast isn't reserved to GraphQL anymore. At the time, way back, it was. If you were trying to make changes between backend and frontend and have everything behave, it made a lot of sense to use something like GraphQL. There are still places where it makes a ton of sense, and if you want to know more about that, you should check out my talk at the keynote of GraphQL Conf last year, where I go in depth on why I think GraphQL is a great solution for teams that have different backend and frontend technologies, often different backend and frontend teams. When I worked at Twitch, we were in the process of moving the backend to Go and the frontend to React and TypeScript, and GraphQL was the glue that held it all together. It let the backend teams go do their things, let the frontend teams go do their things, and we were able to pull it all together in a way that was a great experience for everyone. That was a magical thing, and it's a big part of why I was able to move more in the front-end direction. Before we had GraphQL at Twitch, I was entirely stuck on backend because if the backend didn't work, nothing else could be done. Even if I wanted to work on the front end, I had to spend so much time on backend just making sure it behaved. But then, when we moved to GraphQL, and we could define a spec through the schema that said exactly what we should be expecting, everything got so much easier to work with, contribute to, etc. As such, I think GraphQL is a great solution when you have backend teams and front-end teams using different technologies, not even talking to each other a whole lot, and the schema layer that you can define in the middle lets you agree, make this contract, and go and do your own things. There's a lot of additional benefits to GraphQL that I'm not as interested in, but I think that core distinction, the team and company structure distinction, is where GraphQL makes a lot of sense. Here's a tweet I made a while ago that I think still, for the most part, holds true. We obviously have things like server components now that make it a little more interesting. But if your back and front end are both TypeScript, and they're the same team too, cool, use tRPC. If the backend isn't TypeScript and the front end is, GraphQL is a solid solution. But if REST makes sense for you, cool, you can use that too. If it's different teams and they're not TypeScript on the backend, GraphQL makes sense for all of that. And if it's a different company, which means that the ability to consume the code and keep things up to date through the schema layer directly is much more complex, just use REST. GraphQL for external APIs, like being a developer querying against something like, I don't know, GitHub using their GraphQL API, it's a miserable experience. And usually when people use GraphQL for public APIs, they're just reinventing REST, but worst. But if you're structuring your company in a way that GraphQL makes sense, cool, you should use it. But a lot of people adopted it too early. The same way they throw Kubernetes at everything because Google uses it, they were throwing GraphQL at everything because Facebook uses it. And GraphQL is not that simple. It's not that simple at all. And translating from TypeScript to GraphQL to TypeScript again is stupid. Why are we talking about all this? Well, I saw an article. Why, after 6 years, I'm over GraphQL. And I'll take the opportunity to talk about it, but I had to give that preamble because I want to be very clear, I'm not anti-GraphQL, even though people seem to think I am, just because I like tRPC too. If I can use tRPC, I will. And if I can't, GraphQL is my next choice. Let's dive in. GraphQL is an incredible piece of technology that has captured a lot of mindshare since I first started slinging it in production back in 2018. You won't have to look far back on this rather inactive blog to see that I've previously championed this technology. After building many a React SPA on top of a hodgepodge of untyped JSON REST APIs, I found GraphQL to be a breath of fresh air. I was truly a GraphQL hype train member. I feel similarly here. Once you go all in on type safety, you get really into the fact that not having that safety through a JSON REST call is terrifying. Not actually knowing what data you got back from the server and having to guess and hope you got all the fields right, it sucks. And I'm thankful I haven't had to do that for a long time now because I've went all in on type safety. However, as the years have gone on and I have had the opportunity to deploy to environments where non-functional requirements like security, performance, and maintainability were more of a concern, my perspective has changed. In this article, I would like to take you through why today I would not recommend GraphQL to most people and what I think are better alternatives. Throughout, I'll use Ruby code with the excellent GraphQL Ruby lib for examples, but I believe many of these problems are ubiquitous across the choices of languages as well as GraphQL libraries. I have a lot more experience in things that aren't GraphQL Ruby. I played with it a lot in Elixir, but I used it most heavily in Go and Apollo, so those will be my references, but we'll be interested to see how our experiences have differed. If you know of better solutions and mitigations, please do leave a comment. Now let's begin. Attack surface. Oh boy, this is one of my favorite GraphQL points, and it is a very, very valid one. It was obvious from GraphQL's beginning that exposing a query language to untrusted clients increases the attack surface of the application. Nevertheless, the variety of attacks to consider was even broader than I imagined, and mitigating them is quite a burden. Here's the worst I've had to deal with over the years. Authorization. Oh boy. I think this is the most widely understood risk of GraphQL, so I won't go into too much depth here. TLDR. If you expose a fully self-documenting query API to all clients, you better be damn sure that every field is authorized against the current user appropriately to the context of which the field is being fetched. Initially, authorizing objects seems like enough, but this quickly becomes insufficient. For example, say that you're the Twitter API, where we have user, where you get their handle and their email, but we also have on our user object a list of blocked users. Obviously, we shouldn't be able to see a user's PII just because you can view their user and get their handle in these things. And you shouldn't even be able to see certain public info because the context matters. One must wonder how much GraphQL holds responsibility for broken access control climbing to the OWASP's top 10 #1 spot. You guys are curious what this is? Open Worldwide Application Security Protocol. It's an online community that produces freely available articles, methodologies, documentation tools, and tech in the field of IoT. It's a group of people that keep track of the most common and problematic security issues. And broken access control has climbed all the way to the #1. It was in the #5 slot before, so that's a pretty big jump. And the theory here is that a big part of why is GraphQL. And honestly, I can see it. One mitigation here is making your API secure by default and integrating with your GraphQL library's authorization framework. Every object returned and/or field resolved, your authorization system is called to confirm that the current user does indeed have access. Compare this to the REST world, where generally speaking, you would authorize every endpoint, which is a far smaller task. Funny enough, this is the case with tRPC as well, because it's so easy to define an endpoint, you just define the right endpoint. And Gabriel's making a good point here too, where if every single field of every single query has to be authenticated itself, the amount of overhead just to get that data is insane. Fun new thing that just happened. Happy this got revealed to us. If you want proof that GraphQL security isn't easy, a threat actor claims to have extracted more than 200 million recent records from Facebook and Instagram, all by hitting their GraphQL API. Super, super fun. Yeah, this shit ain't easy. Now let's talk about rate limiting. Rate limiting is going to be super fun for this for a bunch of reasons, and I actually have stories here about Twitch outages I caused that will make this even more fun. With GraphQL, we cannot assume that all requests are equally hard on the server. There is no limit to how big a query can be. Even in a completely empty schema, the types exposed for introspection are cyclical, so it is possible to craft a valid query that returns megabytes of JSON. The cyclic thing is not super common. It's actually kind of annoyingly hard to do recursive definitions in a schema, but you kind of can. You can definitely get way more data than you expect. I just tested this against a very popular website's GraphQL API Explorer, and I got a 500 response back after 10 seconds. I just ate 10 seconds of someone's CPU time running white space removed 128-byte query, and it doesn't even require me to be logged in. I'll tell you my story now. So we have this basic GraphQL query. We're grabbing user ID 1, we have their ID and their name. If we look at Twitch chat here, you'll see a lot of other things that are here. We have how long this person has been watching this channel for. Their account was created on August 5th, 2017. We have their badges. So this person's a moderator, they're a tier 3 sub, and they have the Prime Gaming or badge as well. These are all different fields we might want. It's also worth noting these fields are specific to the channel. So he has moderator on this channel, but not other channels. So we're not actually querying user, we're querying channel with, we'll say ID Theo. And then under here, we're querying users. So within here, certain fields will be different. Maybe we have a chat color. Maybe we have message history, which is its own separate subfield that we have to deal with now too, that has other things like message, contents, sent at, those types of things. And maybe, probably important, we should keep track of the badges. So let's grab badges. And badges have a few things too. They have IDs, they have image URLs, they have a lot of these different fields that are important. I should have name too, because every badge has a name. So now we have a pretty representative query of something that you would absolutely do at Twitch. So looking at this query, if I was to tell you that one of these fields took down the chat service at Twitch, which one do you think it is? Looking at this pretty innocent query, what here do you think had the ability to not just take down chat, but it also almost took down payments? Seeing some good answers here. The history, the message, or the sent at, these types of things, all sounds logical. What if I told you it was badges? One of the ways your badges are determined is by what you've paid for on Twitch. This badge that Gabriel has is a tier 3 sub badge that he's had for 23 months. In order to have that, he has to have paid for it. So the payment service gets hit every time you query badges. Because of that, the official way that badges, the query was being used on Twitch, was that this was almost never actually called, except for one place really early on where the badge values would be preloaded for chat. I can prove this by showing here, if I change my badge, I'll change it to the GLHF pledge. I'll send a message, Notice that my badge is still that badge. I'll send another. Oh, it's not going to, no, it should swap. Third times the charm. No, it's not swapping at all. Will it not do it? It should be eventually. Nope, maybe I have to refresh to see it. Nope, cool. We'll go to another small streamer's channel. You guys might not have heard of him. Hi, Prime. I'm using your chat for a demo. Here it has that badge that I switched to. And now I'll switch it back to my partner badge. Trying once more. Oh, it actually switched first time that time. Usually, when you switch your badge, it actually takes a message or two to properly swap over. Almost always does. I've had this problem for as long as I've been using Twitch. One more. Oh, cool. It's actually switching immediately now. That's a new change. That's a really nice, cool new thing that didn't work that way before. And the reason it didn't work that way before is because all of the badges were queried really early and then not queried again until they had to be. Because it turns out querying badges on user, which seems like the most innocent thing in the world, is not. And even though the service that we did this on was a relatively minimal service, it was twitch.tv/moderator. And I'll hop into my channel here, moderate my own channel. If you're not familiar, ModView is the most proud I've been of anything I built at Twitch by a lot. It's one of the projects I'm most proud of, period. And one of the things we have here is this list of people in the community, specifically the list of moderators. We used to fetch the badges for each of these people so we could see what Agor's badges were, what Embed's badges were, what Fossipot's badges were. Notice that we're not showing the badges now. The reason is because despite this page being relatively not common for people to hit, even the day we launched it, like 1 in probably 10,000 Twitch sessions go to this page. They're heavy users, of course, that will go to this page and sit on it for a while, but we weren't firing this query a whole lot. Like it wasn't happening a ton or anything. It's not like we went out of our way to query this constantly or that it was being used on every single page on the site. It was a very small percentage of users on this page that fires this query once every, I think it was every minute or two at worst. And that was enough to almost take down payments for all of Twitch because a query as innocent as badges, getting these tiny little icons next to your name was enough to almost take down critical infrastructure at Twitch. So yeah, rate limiting is important. And also clearly documenting on every one of these fields which ones do and don't have to figure these things out. Because like I would never have written this query and assumed that I should go talk to the chat and badges team to make sure that calling the field badges wasn't going to take down Twitch. That makes no sense at all. So yeah, this is the issue. I just cannot fathom dealing with this at scale without doing a lot of work. A really good response to the issue that I described with badges would be, why don't the resources just expose a cached value instead? Great question. Ask the team that built the badges endpoint here that added this field in and tried to get my team in trouble for using it. Because I agree, they should have been caching it. But I had to die on a sword, even though I didn't write this query, because my team was getting shit for it, and I didn't want them to go through Git blame and go after somebody who deserved a promotion that was already struggling to get it. They were trying to start shit with her and with my team because they suck at API design. Nothing here indicates that I shouldn't be calling badges. They put no work into it whatsoever. Should I have went through and audited every single GraphQL query in my app to make sure that they were being cached properly and that every team was okay with me using it? Sure. This project would have taken us 3 times longer to ship. We built it in 6 months. It would have taken 1.5 years. I am confident in saying that. But yes, you are totally right, Nihil. The resource should absolutely have exposed the cache value rather than make it my problem and then go to like my execs to try and get me in trouble for it, which is what they did instead. Yeah, caching is hard, so go to HR instead. Anyways, apparently Shopify had this problem too. Rate limiting GraphQL APIs by calculating query complexity. Fascinating. The things we have to do to make these solutions work are insane. You know, I'm happy he called this one out because I should talk about this one more. And I love the opportunity to complain about the issues I've had because, yeah, this sucks. And there isn't a clear solution here. Here's the common mitigation for this attack, by the way. He's calling it an attack because if you find something that's slow, you can just destroy them by calling queries like this. Common mitigation for this attack is the following: to estimate the complexity for resolving every single field in the schema, and then abandon queries that exceed some maximum complexity value, and to capture the actual complexity of the query and take it out of the bucket of credits that resets at some interval. Now you're building your own crazy like DIY rate limiters because certain fields take too long to query. The calculation is a delicate affair to get right. This is linking to the GraphQL Ruby page, preventing complex queries. Fields have a complexity value, which can be configured in their definition. It can be a constant numeric value or a proc. If no complexity is defined for a field, it will default to a value of 1. it can be defined as a keyword or inside the configuration block. That's nice. Having a complexity field that you can define in their layer is nice. I hope that's exposed in a way that's actually useful when you're querying against it. It's a good step in the right direction, though. But also, you could easily make an assumption about the complexity of these queries, and if they are wrong, you might end up rate limiting valid queries or not rate limiting the invalid ones. To make matters worse, it's common for the graph that makes up the schema to contain cycles. Let's say you run a blog with articles, which each have multiple tags, from which you can see the associated articles. So we have type tag, name string, related tags, tag, and then type article has tags as well. Have fun. When estimating the complexity of tag.related tags, you might assume that an article will never have more than 5 tags, so you set the field's complexity to 5, or 5 times its children's complexity. The problem here is that article.related tags can be its own child, so your estimate's inaccuracy could compound exponentially. The formula is n to the power of 5 times 1, so given this query, you can expect 5 to the power of 5 is a 3,125 complexity. If an attacker is able to find an article with 10 tags, they can trigger a query with a true complexity of 100,000, which is 20 times greater than what you estimated. So being very slightly off on your estimate. You go from an article with 5 tags to one with 10, it's that easy to just swamp your service. Partial mitigation here is to prevent deeply nested queries. However, the example above demonstrates that this is not really a defense, as it's not an unusually deep query. GraphQL Ruby's default maximum depth is 13, and this is only a depth of 7. Yep. Compare this to rate limiting a REST endpoint, which generally has comparable response times. In this case, all you need is a bucketed rate limiter that prevents a user from exceeding, say, 200 requests per minute across all endpoints. If you do have slow endpoints, like a CSV report or a PDF generator, you can define more aggressive rate limits for these. With some HTTP middleware, this is pretty trivial. Yeah, totally agree. I want to showcase how easy it is to add rate limiting using tRPC, because I think this actually showcases why I like tRPC's flexibility so much. We're going to clone my first T3 stack project. This is my first public example of tRPC, roundestmon. If you go to my channel and you look at the oldest video, you'll see this. npm install. These will all be installed. It will load Prisma and all of that. And now I have my project. Dope. All the type definitions all work as expected. I have this cast vote endpoint, and I want to make sure people can't abuse it. Since the cast vote endpoint is a mutation that isn't a graph where you're chaining and defining on the client side what you are and aren't using, it's literally just a mutation that you call on the client side. I can do whatever I want to in here. If I want this cast vote mutation to be protected differently from the get Pokemon pair query, cool, it's easy to do. I just do it here. Let's do it. I will go grab the rate limiter I prefer, which is Upstash, which has sponsored me in the past. I have not asked them to up our sponsor again because I feel like I have not done enough for them. I like the product a lot, genuinely, and highly recommend it. And they have a great rate limiter. So we can just install upstash/redis and upstash/rate limit, npm install upstash/redis, upstash/rate limit. Now I have these two packages. If you're not familiar with what Upstash is, it is Redis as a service, as well as Kafka and the new VectorDB and QStash. Mostly the Redis side is what I'm familiar with, and they built really, really nice stuff on top. Even if you're not using Upstash, their Redis stuff is the best way to use Redis and TypeScript by a lot. Yeah, they're using the Point Manager theme. Didn't even notice that. Good call out. Good theme. So now we have all this. We can go make our rate limiter. I could paste it on top here. I'll just throw it in a new file though, because sure. Rate limiter.ts, paste, export, const, rate limiter, or rate limit. And now in here, I import, paste, autocomplete, cool. Now I can call the rate limit function. Const success is await rate limiter.limit. We need to identify the user in some way. Thankfully, we have a bunch of stuff here that might be helpful. We have the context. And in the context, we have useful fields like context dot. Was this before we passed the request? Because this was pre-create T3 app. Okay, we're just going to whiff it. This is an old tRPC project, so I don't actually have the request bound to the context. So I'm just lying here. In your project, if you used create T3 app, this will all just work fine. We want to limit by something unique to this user. It's pretty easy to do. Request dot. And in here, we have a bunch of info. One of the things we'll have is request.headers.ip. Oh, just request.ip. Nice, look at that. So I can literally just call request.ip if we're using Vercel. You might be mad about the type here. That's fine, I don't care. Now, we're rate limiting by their IP address. Isn't that nice? It's that simple. We call a rate limiter with something that's uniquely identifying. If we want to make it specific to this endpoint, we can do that too. Cast vote plus request.ip. Now, this user can only call this thing a certain amount. If we want to configure it, obviously that's an option too. We hop over here. Well, I guess the rate limiter itself has this defined. So if we go back to the rate limiter object, if I want this to be only callable once every 10 seconds, now it is. I want it to be callable 20 times every 30 minutes. Now it is. Isn't that nice? You just call it. I am not actually using it though, which is important, which I should do here. So if no success, throw a new error, rate limited. And now we can get them out here, kick them out of what they're doing before we even get to the code that actually runs. So yes, technically speaking, they're able to get this code to run over and over, but it doesn't really matter because none of this code is actually slow. And since our endpoints are specific to our needs, this is easy to do. The big inversion going from something like GraphQL to something like TRPC is that with GraphQL, you define the query in the client. So if you need a Pokemon pair that has these values in it, then you would define on the client the actual GraphQL query that you're firing, and then fire that from the client. And then the server gets that query, parses for what exactly you're actually looking for, and then validates all those fields and then sends it to you. With TRPC, it's inverted. If you want a different query, if you want different data in the query, you don't on the client say, hey, I want different data. You go to your server and you add the data. Or if you don't want to overuse a given field, like let's say I want get Pokemon triplet instead of pair. I'm not going to add a third option to get Pokemon pair. I'm not going to add more options because I could just make get Pokemon triplet. And now I can do different things in here. It's so easy to define new queries with TRPC that you don't often find yourself wishing on the client side that you could call any permutation of a query. If the existing API doesn't give you exactly what you need, go copy paste it and make a new one. It's super easy to do that. And then every single API endpoint, in quotes, because this all is going through one endpoint anyways, they all be batched the same way too. Each one of these is trivial to validate. The reality is that the thing we want to validate isn't your access to a given field, it's your access to a given call. If we go back to this example, if I could validate this query upon writing it to say this query can only be ran if it has these properties or you have these permissions, that'd be great. But you don't write queries on the back end in GraphQL. You write queries on the front end, you write schemas on the back end. And that's the difference. With TRPC, you define the queries on the back end, and with GraphQL, you define them on the front end. This is the issue. And the reason this made sense is because defining APIs on the backend used to be so hard that if the backend just exposed everything and the front end could say what it wanted, that seemed great. But if you could just go define the right thing on the backend by just writing a function, the need for that goes away really quickly. TRPC made API so easy that I unfortunately have no other option than to confront my bad UI design skills. You do have another option. You do what I did, become an influencer, because I had the same thing. When doing this stuff got so easy, I ended up becoming a content creator because I just wanted people to see how easy this could be. But yeah, I totally agree. Rate limiting's a real problem. It's caused a lot of trouble for me in the past, and TRPC, along with any rate limiter, just makes this trivial. Speaking of things that aren't trivial, we need to talk about query parsing. Before a query is executed, it is first parsed. We once received a pen test report evidencing that it's possible to craft an invalid query string that out of memory to the server. Okay, this is where we're getting into the Railsisms, but yeah. It's a syntactically valid query, but it's invalid for our schema. A spec-compliant server will parse this and start building an error response containing thousands of errors, which we found consumed 2,000 times more memory than the query string itself. Because of this memory amplification, it's not enough to just limit the payload size, as you will have valid queries that are larger than the smallest dangerous malicious one. Yep. If your server exposes a concept of maximum number of errors to accrue before abandoning parsing, this can be mitigated. If not, you have to roll your own solution. There is no REST equivalent to this attack of this severity. Yep. You have to limit the query size too. Even if you do limit the query size, you might still be fucked because this query is tiny. Still tiny, and you can ruin things with it. Performance. When it comes to performance in GraphQL, people often talk about its incompatibility with HTTP caching. This is a fun one. If you don't know this already, GraphQL calls are all done through post because you need to have a body, and you can't have a body in a get. With a traditional API call, you just put the things in the URL, and each URL is unique to one query, so it can return the specific stuff. Technically, you can pass a body via query params, but it's a bit of a mess. Yeah. The issue here is that when you need a body, because you only have one endpoint, and then you're trying to send the query shape to that, you can't just throw this in your URL. So you need somewhere to put it. So you put it in post. And that's now how every GraphQL endpoint works. With TRPC, you don't have to worry about that because your endpoint's pretty simple, pretty dumb, pretty easy to hit, and everything's just encoded in the URL. Works great. And then when you transform the response to a super JSON, you don't even worry about things being formatted wrong, like dates. It just all works. It's really, really nice. When it comes to performance in GraphQL, people often talk about its incompatibility with HTTP caching. Yeah, if you're not using gets and you're only using posts, good luck caching it. For me personally, this has not been an issue. Yeah, fair. Not for everybody, but when it is, it sucks. The inability to cache common things does suck. For SaaS applications, data is usually highly user-specific, and serving stale data is unacceptable. So I've not found myself missing response caches or the cache invalidations bugs that they cause. The major performance problems I did find myself dealing with were the following. Data fetching and the N+1 problem. Oh boy. I think the issue is pretty widely understood nowadays. TLDR. If a field resolver hits an external data source, such as a DB or an HTTP API, and it is nested in a list containing n items, it will do those calls n times. So to go back to my example query here, if each of these messages, when it gets your message history, has to hit an endpoint to get the data, then if you have n messages, or let's say 5 messages, you now have to hit that API 5 times, or hit the database 5 times. You can't query all 5 at once. This is not a unique problem to GraphQL, and actually the strict GraphQL resolution algorithm has allowed most libraries to share common solutions, specifically the data loader pattern. Unique to GraphQL, though, is the fact that since it is a query language, this can become a problem with no backend changes when a client modifies a query. Yep, it's very easy for you to suddenly go down because somebody on client queried in a way you weren't expecting. As a result, I found you end up having to defensively introduce the data loader abstraction everywhere, just in case a client ends up fetching a field in a list context in the future. This is a lot of boilerplate to write and maintain. Meanwhile, in REST, we can generally hoist nested N+1 queries up to the controller, which I think is a pattern much easier to wrap your head around. Yeah, just grab up to 25 posts, including author and tags, and then respond with that as JSON. Nice. No prefetching necessary here since n equals 1. Yeah, cool. Authorization and the N+1 problem. Oh boy, here's where it gets really funny. If you follow the advice earlier of integrating with your library's authorization framework, you've now got a whole new category of N+1 problems to deal with. Let's continue with our XAPI example from before. If we have field handle and a field birthday, which can only be authorized if you have this permission, and now we've defined view PII as you are friends with this person. Oh no, I hit the DB to fetch the user's friends. Now, when I fetch all of their friends and I have to check all of those birthday calls against user.friendsWith, for every single one of my friends, I'm now firing an additional GraphQL query, well, an additional database query, just to confirm that they actually have permission to see birthday. This is actually trickier to deal with than our previous example because authorization code is not always run in a GraphQL context. It may, for example, be run in a background job or on an HTML endpoint. That means we can't just reach for a data loader natively, because data loaders expect to be run from within GraphQL, at least in the Ruby implementation. In my experience, this is actually the biggest source of performance issues. I am amazed at how common this is, that over-authentication and authentication checking constantly, or having a bunch of waterfalled queries where you're running 15 queries that could have been one, and now you're re-authing for each one. Checking auth an unnecessary amount of times is so weirdly common a pattern. And I don't just mean that the user is the user, but the user has permission to do this thing. We would regularly find that our queries were spending more time authorizing data than anything else. Again, this problem simply does not exist in the REST world. Yep. I've mitigated this using nasty things like request level globals to memoize data across policy calls, but it never felt great. Coupling. In my experience, in a mature GraphQL codebase, your business logic is forced into the transport layer. This happens through a number of mechanisms, some of which we've already talked about, like solving data authorization leading to peppering authorization rules throughout the GraphQL types, solving mutations in argument authorization leading to peppering auth rules throughout your GraphQL arguments, solving resolver data fetching N+1s leads to moving this logic into GraphQL-specific data loaders. Yep, you'll notice a pattern here, where just in order to solve GraphQL, we have to do something on top. Or the best option here is leveraging the lovely relay connection pattern, which leads to moving data fetching logic into the GraphQL-specific custom connection objects. Joy. The net effect of all of this is to meaningfully test your application, you must exclusively test at the integration layer, i.e. by running a GraphQL query. I have found this makes for a painful experience. Any errors encountered are captured by the framework, leading to the fun task of reading stack traces in JSON GraphQL error responses. Since so much around authorization and data loaders happens inside the framework, debugging is often much harder, as the breakpoint you want is not in application code. How does REST solve not having to make a DB call to determine whether or not to show the friend? Because you can make it once rather than making it a whole bunch. The issue on that example is that because I'm fetching friends, the context of these people being my friends is lost by the time we're checking birthday, because the birthday field itself, the auth check is happening here, not here. If you did this with a REST API or with a tRPC API or with a server component or server actions, you just get your friends and now you know you can safely get their birthdays because they're already your friends. You know that because the get my friends query or the /my friends API endpoint, once the data's fetched, it is implicitly checking when getting friends that they're your friends. We don't have to recheck this field from the user type because birthday is authenticated on the friend level because it's a user object here, not on the me level. If we could authenticate me instead of authenticating each friend relative to me, it's one check instead of number of friends checks. And now everyone's favorite thing to complain about, complexity. Taking in aggregate, the various mitigations to security and performance issues that we've gone through add significant complexity to a code base. It's not that REST does not have these problems, though it certainly has fewer. It's just that the REST solutions are generally much simpler for a backend developer to implement and understand. And another big part here is that it all can live in like one file. It's so much simpler to just read a file top to bottom and see exactly what it's doing for your API endpoints versus the craziness hopping between your transport layer, your framework's docs, your different fields and how they're being authenticated, the authentication bindings on subfields and all these different models and all this chaos sucks. Having it just top to bottom reading one thing makes life so much simpler. It's the same reason I like the way React does state. Technically, you can just return authorization errors on the GraphQL field itself, birthday, rather than on the parent field, me. Yeah, but the friends object is a user object. If we defined a separate object for friends, maybe. But the reason this is happening here is because on the user object, we've bound authorize with. So could we error out that you can't query friends if you're not you? Sure. But now we have to make a whole separate user type for friends too, and make sure everything in here is safe to query. And that's not how reality ends up working almost ever. Let's go through the and more here quick. So those are the major reasons I am, for the most part, over GraphQL. I have a few more peeves, but to keep the article from growing further, I'll summarize them below. GraphQL discourages breaking changes and provides no tools to deal with them. Oh man. Yeah, versioning and breaking changes on your GraphQL APIs is miserable. This adds needless complexity for those who control all of their clients, who will have to find workarounds instead. Reliance on HTTP response codes turns up everywhere in tooling, so dealing with the fact that 200 can mean everything from everything is okay to everything is down can be quite annoying. That's another fun thing. GraphQL endpoints will always respond with a 200, even if it's an error. That means you can get them cached too. Wait, you can't because it's all post. Even more fun. Fetching all your data in one query in the HTTP 2+ age is often not beneficial to response time. In fact, it will worsen it if your server is not parallelized versus sending separate requests to separate servers to process in parallel. Streaming makes this much easier, but sure. Alternatives. Okay, end of rant. What would I recommend instead? To be upfront, I'm definitely early in the hype cycle here, but right now my view is the following. If you control your clients, you have less than 3 clients, you have a client written in a statically typed language, and you're using greater than one language across all servers and clients, you're probably better off exposing an OpenAPI 3.0 compliant JSON REST API. If, as in my experience, the main thing your front-end devs like about GraphQL is its self-documenting type-safe nature, I think this will work well for you. I don't think this is a great summary of what front-end devs like. The way I would put it is that front-end devs like that they feel less blocked by a GraphQL API than a REST API. With GraphQL, all of the permutations of the existing data could be accessed without touching a backend dev. I can just write the endpoint I need by hopping in my front-end file and writing a new query as long as all the fields already exist. With REST APIs, if I need different data or I need a different shape of data, either I call 5 different things on client and mangle them together, which is very, very common, or I bug the backend guys to go make some changes and hope they actually get made within time. That's the main thing I liked GraphQL for, is that I didn't have to bug backend to make new experiences for users. And I also didn't have to make these crazy piles of queries and then attach them all together after making a bunch of AJAX calls on client. Now all of that attaching is going on in server, which isn't better. To again go to tRPC, the reason I think that is such a great experience is because you can just go write the query on the back end. You don't have to do it this way at all, which is a really, really nice change. Tooling in this area has improved a lot since GraphQL came onto the scene. There are many options for generating typed client code, even down to framework-specific data fetching libraries. My experience so far is pretty close to the best parts of what I use GraphQL for without the complexity that Facebook needs. As with GraphQL, there's a couple of implementation approaches though. You can do the OpenAPI spec from a type file. There's a bunch of tools to generate the OpenAPI spec and pipe it to TypeScript. Cool, those all exist now. You can also do a spec first thing where you define the schema ahead of time. Look at that. He even accounted for my tweet. Happy that him and I agree here that if you're only using one language and that language is TypeScript, you should be using tRPC. Nice that I don't have to emphasize that separately because he even calls it out. A language-specific solution like tRPC might be a better fit. Yep, totally agree. This was a great article. It's nice that the GraphQL fanboys are acknowledging the flaws now and pointing out what the actual experience was like maintaining these things over time. Matt Bessie, you killed it with this one. Great blog post. Link in the description if anybody wants to read it and look more into it more in the future. That's all I think I have on this one though. I have not touched GraphQL for a while, not because it's bad, but because all of the things we just discussed are not pleasant unless you really, really, really need the benefits. Let me know what you think, though. I'm sure a lot of you still like GraphQL. I'm sure a lot of you absolutely hate it. I'm still in the middle, but I hope this is useful context. Until next time, peace, nerds.